This is Geometry Unit 4, Lesson 2 on rotations. Rotations are the second type of transformation that we're going to look at in this unit. A rotation, by definition, is a turn around a fixed point. When I think of a rotation, I think of a steering wheel. Here's the steering wheel. Here's the center point of your steering wheel. And if you have your hands on your steering wheel, like here and here, and you turn your steering wheel, does the center ever turn? No, the center stays where it is. It's the wheel itself that turns. These points will go around the steering wheel wherever your hands are. So if your hands end up here, they will turn to end up over here somewhere. So the center never moves. So all points rotate around a given point P by a given angle theta. It does not have to be 180 degrees. Okay, now remember, P is your fixed point. That would be, for example, the center of your rotation. So that would be like here would be point P on your steering wheel. Now, the angle theta, you can actually turn however many degrees you want to turn. Theta just stands for some angle that we're going to turn. We don't know what it is. All right, so each point will rotate whatever degrees around P. That's what this means. So if you're rotating around a given point P by a given angle theta. All right, so if you are looking at, this is a rotation, this would be your center of rotation P, and you're going to turn this way. So if we look at it as a turn from here, and A ends up at A prime right here, this is the angle that it turns right here. This would be theta, whatever it happens to be. If it's 45 degrees, 60 degrees, 90 degrees, whatever it happens to be. It doesn't have to be 180, it can be any turn. So the measure of angle A, P, A prime will equal theta, whatever this angle value is. Now, if we do another point, so we take point B. Point B will turn exactly the same way. So if you go from B to P to B prime, right here, this angle here will be theta. It's exactly the same. So the measure of angle B, P, B prime will also equal theta. And guess what C will be? If we do C, let me do it in green. If I go from C to P prime, that measure will also be theta. Every single point turns exactly the same degrees around point P. So all those will be the same thing. So they were all equal theta. Every point turns exactly the same degree measure. Now it's important to be able to understand the notation for rotations. Remember, a reflection was a lowercase r. A rotation is an uppercase R. Capital R with a subscript of P comma theta means a rotation about a point P, which is your center of rotation, of theta degrees. Now, it's important to recognize when you see this, if theta is positive, the turn is counterclockwise. Now, I know that seems weird, but a positive angle will turn like this. That would be positive. So if theta is negative, the turn would be clockwise. Think of it like on a coordinate plane. When you do the quadrants, you're going from first to second quadrant. It always goes to the right, or to the left, excuse me. So positive theta would be counterclockwise. Negative theta would be clockwise. So you have to know if theta is positive. So if you said 75 degrees positive, it would be going 75 degrees that way. If you said negative 75 degrees, it would go 75 degrees this way. So it's very important to understand which way to turn when you're doing theta. A positive theta means you're turning counterclockwise. So now let's look at the properties of rotations. When you rotate something, the center of rotation is invariant. Remember, invariant means fixed or unchanged. It doesn't change. For all other points Q, the image of Q prime is the point such that the measure of QP, Q theta, or Q prime is theta. And PQ will equal PQ prime, sorry. All right, so what I'm saying on this, when you move the angle for any other point, when you do the rotation, the angle theta moves, whatever you do from Q to Q prime, the angle measure will be theta, and the length of the segment PQ will stay the same. It will become PQ prime. The distance will be the same. So distances are preserved. AB will be congruent to A prime, B prime. If I look at my picture here, here is AB here. There's AB, and here's A prime, B prime. Notice they are exactly the same length. They didn't change length at all. All of the sides will stay the same. So AB will equal AB prime, A prime, B prime. BC will be congruent to B prime, C prime. And CA will be congruent to C prime, A prime. If you turn something, you're not changing its size, so the distances are preserved. And so are the angle measures. If we look at our angle measures here, angle A here will be the same as angle A prime here. B will be the same as B prime. C will be the same as C prime. All of the angles measures stay the same. We do not change the angle measures. So angle A will be congruent to angle A prime. Angle B will be congruent to angle B prime. And angle C will be congruent to angle C prime. The size and the shape of the image is unchanged. What you end up with is what you start with. Now, there are a couple special cases of notation that you run into when you're doing rotations. R of theta. If you don't have a point specified, that means you're on the coordinate plane. R of theta, it means rotate theta degrees around the origin, which would be the point 0, 0 would be your fixed point. So you're going around the center of the value. You may also see that as R of O. Sometimes you may see it as that, rotation around the origin. Now, R of P with no angle specified means rotate 180 degrees around point P. So if you don't specify an angle, that they want you to do rotate around P a certain 180 degrees exactly. That's a special one. Now, rotating around the origin is a little bit tricky. You have to be really careful about thinking about how many degrees you are turning. So let's look at A. We have point A that has coordinates of 4, 2. This is the point 4, 2 right here. Now, if I want to rotate this 90 degrees around 4, 2, now I want to turn this so it's fixed around the origin. The origin is my fixed point. So I want to imagine that I am turning this point like the wheel going around. So this has to stay in place. So if I want to turn this 90 degrees, let me do a dotted line so you can see what I'm talking about here. I am going to use the origin as my fixed point, and I want to go 90 degrees on the opposite side. Well, let's see what happens when we end up at 90 degrees. Well, if I can draw a 90-degree angle here, I would end up like so. That would be 90 degrees like so, and I end up at the point here. So A prime right here would be at 2, 4. Or negative 2, 4, I'm sorry. Negative 2, 4. So what happened to the coordinates when we did that? Negative 2, 4 started out as 4, 2. Well, they switched and changed the y. So this became negative y x. So you switch and negate the y. And that is a rotation of 90 degrees. All right, now, what if I went 180 degrees? All right, so if I'm going 180 degrees, I want to make basically a straight line. Okay, so if I extend this down through here, whoops, make a nice straight line, I end up at that point right there. I end up at negative 4, negative 2. All right, so how did I change from the original 4, 2? What happened to the coordinates? So you negate both coordinates. So if you negate both coordinates, this becomes negative x, negative y. So the rule for rotating 180 degrees is negative x, negative y. You may also see it like this. R of O of xy, that means rotate about the origin. O stands for origin, and that will be negative x, negative y. So if you're rotating around the origin, that means to go through the origin to the opposite side, you end up over here at -4, -2. Okay, now 270 degrees. That is rotating 90 degrees 3 times, or 90 degrees past 180. So you would go 90 degrees, 180 degrees, and then 270 degrees to make your 90-degree angle would have to be something like that. So you would go around like this 270 degrees. You end up at the point here to -4. So if we went 270 degrees, what happened to the coordinates? Well, they ended up being switched and negate the x this time. All right, so you end up at y -8. Now, if you went 270 degrees counterclockwise, which is positive, how much would you have to go negative? It would be the same as rotating -90 degrees. So when you see rotations, it's very important to know your rules. If you know rotation of 90 and rotation of 180, those are very, very important. 270 you can kind of figure out based on those, but you need to know your rules. Okay, so you have to know how to do 90 and 180, and then you can figure out 270 from that. All right, so that is the rotations about the origin. Remember that your center is fixed. Rotations that are positive angles go counterclockwise, negative angles go clockwise. So be very careful of that. Always know what your angle measure is and how to turn it when you do it. So that is rotations about the origin.